Assalamualaikum and hello everyone. Today we want to present about application of convolutional neural network CNN for classification and detection tasks. So we are from group number 7. So our team member consists of first one is myself, Muhammad Adif Syafiq bin Zamani, Wan Muhammad Syakir, Muhammad Faiz Amiruddin and Muhammad Adif Aiman. We go to the introduction. Convolutional neural networks CNNs are artificial neural networks developed for image recognition and processing, utilizing deep learning for generative and descriptive tasks. They are often used in machine vision, including image and video recognition, recommender system, and natural language processing. Traditional neural networks, which are not optimal for image processing due to reduced resolution, require feeding image with reduced resolutions. CNNs are a multi-layer perceptron system similar to a multi-layer perceptron with an input, output, and hidden layer consisting of multiple convolutional layers, pooling layers, fully connected layers, and normalization layers. This system removes limitation and increase efficiency, making it more powerful, easier to train, and more flexible, applicable to both natural language processing and image processing. So this is the task 1 model question that or task that have been given to us. So I will explain more about task 1. So we go to the methodology. Convolutional neural networks and stands as pivotal breakthrough in artificial intelligence, specifically tailored for the intricate analysis of visual data, encompassing image and video, notable for its efficacy in image recognition and classification tasks. A CNN operates by autonomously acquiring a discerning distinctive features from input data through the application of convolutional filters. This unique architecture enables CNNs to excel in discerning complex patterns and hierarchies within visual information, making them a cornerstone in various fields such as computer vision, image processing, and pattern recognition. The adaptability and hierarchical natures of CNNs contribute to their widespread application in cutting-edge technologies and industries. So next we'll go to the demonstrations. So I will explain about the task 1 model 1. So step 1 will connect to the drive, and it says right here output is mount at content Google Drive. So step 2 is feed the dataset directory. If it's successful, it will write like this, where we save the task 1 ICS. Step 3, we need to create train validation data. So this is what we want to create train data directory. So we save at the task 1 ICS. This is train can pet pack directory. So this is print to print the output. So the output is can train length is 580, pet train length is 939, pack train length is 292, can valid train length is 121, pet valid length is 408, and pack valid length is 80. So next we want to construct a CNN model. So this is what we need to construct. So the output is total params is 19034177. So it is 72.61 MB, and trainable params is 19034177, same as total params because there is no trainable params. The next is the step for pre-process the input data. So the output is we found that 1811 is image is belonging to 3 class, and another 609 image belonging to 3 class also. So the data batch shape is 10, 150, 150, and 3. So the level batch shape is 10. So we need to start the training process. So right here is that per epoch is 10, we set is 10, and epoch we set as 100, and validation steps is 100. So this after 100 epoch, this is the outcomes, and next we want to plot the outcome. This is what we write right here, and then you can see this is the plot for the outcome. There is a bit difference between training loss and validation data loss with accuracy. So we can see the training loss and validation loss. The graph is going downwards compared to training and validation accuracy. The graph is almost stable. So I think that's all from me for the task 1 model 1. So for the task 1 model 2, I will pass to my friend Muhammad Shaki.
Assalamualaikum, my name is Muhammad Alif Aiman bin Abdullah. So today I would like to present for the task 2 for the problem statement. So this work focus on developing a unique detection model using you only look on YOLO framework for face mask detection for public health and safety, distinct from the 80 object classes in the COCO dataset. So to address the critical need for public health and safety during a pandemic, this work aims to create a specialized real-time face mask detection mode using the YOLO framework, tailored specially for this task and distinct from the broader object classes in the COCO datasets. For the methodology, first, gather a tagged dataset of picture or video showing buses draw bounding boards around the area that are occupied by buses to annotate the dataset. Make sure a variety of bus variation, viewpoint and environment conditions are covered by the dataset. For the first step, we start by importing necessary library and module. Second step, we mount local Google Drive. For the third step, define 3 paths for training, validation, and test sets. For the fourth step is cloning the YOLO v5 repository from its GitHub repository. For the fifth step, using the pipe installer to install the required dependencies of YOLO v5. For the sixth step, using the wget command to download the YOLO v5 model wake from the specified release version 6 in GitHub. For the seventh step, YOLO v5 repository train.py script to train a customized YOLO v5 model for face mask detection. For the eighth step, make detection on test image. For the ninth step is use OpenCV for displaying the detect image with detect in above cell. For the last step is we detection on the video. That's all from methodology part.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shaki Hamri and the metric is DE20037. Okay, for my part, I'm going to explain for the task 1, model 2. Okay, for the task 1 model 2, we gonna select any state of the art presidency and model and combine with the model 1. Then we using for the transfer learning process. Then after we train the model using the dataset that we have been given, we're gonna set for the approach is 100 to train the process. Then after obtain the graph, we must explain the outcome and compare with the result above. Okay, then we move to our methodology. For methodology is I'm used for the VGG. For the VGG stand for Visual Geometry Group and it's a deep convolutional neural network CNN with 16 layer. It is a popular architecture for object recognition and outperform other tasks and dataset. VGG-Net 16 have 138 million parameter and it has 16-layer deep neural network with 64 filters, which can be doubled to 512. Okay, then we move to our demo to the Google Colab. Okay, for the step 1 is we connect to the drive. From this coding, we gonna connect to our Google Drive that have the dataset that have been downloaded. Then after we mount our Google Drive, for the step 2 is we feed dataset directory. This is dataset directory is connect to our Google Drive that have dataset that I declare for the name is task1 ICS. We can also select it here after we run it. Then for the step 3, we create train validation data directory. Okay, for the first is I declare for the train first for the three type can, pet and tetrapet. Same also for the validation. Okay, after we run it, then we get for the result is cat train length for 580, pet train length 939, then tetrapet train length 292. And after that, we move to our step 4, we construct pre-trained model with BGG16. This is coding for our to construct pre-trained model to our BGG16. Then after we run it, we get the result here. For the step 5 is we pre-process the input data. For the pre-processed input data, we pre-process the image in the dataset, such as the scale, for the size. Then we have the output result here after we run it for the 3 classes. Then for the training process, I declare for the step per epoch is 10. Then for the epoch is 100, same as the in the task that say. For the validation step also 10. Then after we run it, we must wait until the epoch is complete. Okay, after it complete, we continue to the last step. For the step 7 is we must plot the outcome. For the plot the outcome, I plot for the training and validation accuracy, also training loss and validation loss. This is the result after I run it. We compare from these two. We see for the training loss and validation loss is more decreased compared to the training and validation accuracy. Okay, that's all for me for task 1, model 2, VGG. Thank you.
So Assalamualaikum and good day. My name is Muhammad Faiz Amiruddin bin Abdullah. My matrix number is CE200135, and I am going to explain about our second task, which is task 2, detection. And this task 2 is assigned for us to design a custom detection model based on YOLO. And then the it is to identify and locate single class of intended object from a video. So basically, YOLO was trained using COCO dataset with 80 object classes, and our selection of object must not fall within the COCO object class. So basically, we need to identify object of interest to be detected by custom model, and then we need to ensure that we have a valid problem statement to select the object class. So for example, bumper detection, stop sign detection, and then detection sticker detection, person identification, and etc. So for our group, we choose video, we choose our face mask as our main object of detection, and then we need to differentiate in the video. We need to differentiate between a person that wear face mask and person with not with no face mask. So after that, we need to construct the object of interest dataset with minimum 300 images and use data augmentation to boost the number of images. And then we need to annotate the dataset accordingly to increase the training image number. And then we need to train the dataset using our choice of custom YOLO model and record the outcome. And then after that, of course, we need to record a video that contains object of interest and evaluate the custom YOLO performance using recorded video. Alright, so let's go to uh, our collab. So basically, the first step, obviously, we need to import our OS and then shuttle and also random. And after that, we need to import our data from local Google Drive. So basically, my Google Drive is from content and then drive. So if we click on run button, automatically it run and show drive already mounted at our local drive, and then it shows to possibly remount call drive.mount. So basically the coding have successfully call the data from my local drive. Right, so for the third step, we need to make path from this collab to our local drive. So basically, there is three path that we need to call out, which is train, val, and also test. And then, alright, so after that, we need to clone our YOLO v5 from the GitHub. and then automatically it will have make a directory from GitHub into our Google Drive, local drive, and then we need to change the directory to YOLO 5. So basically, we need to import or we need to link our data from Google Drive and also to straight to our YOLO V5. So V5 means the fifth version of YOLO. And then after that, we need to install all requirements from the YOLO itself. So basically, it takes time to install, and then the coding was pip install requirement.txt. So basically, it will install the requirement that we need to use for training dataset. Right. So after that, we can use other than that we can use another command, which is wget https. This is the link that we refer for our YOLO installment, and also to connect our data set to the location or directory to our YOLO v5. So basically, this is the outcome, and it takes for 14.02 megabyte, kilo megabyte in 0.07 second to install our YOLO v5. Right, so after that, we need to include, or we need to insert command for Python train.py. So basically, we need to set our image to 416 and then our batch must be 8 and our epoch is 50. So basically, data is from our local drive, and we need to make sure that the directory of our data set is correct, because this will takes a long time to process, and then it will be a waste if we are not correctly linked to our local drive. Right. So if we see uh, the the outcome from the coding itself, it will show that they have 214 layers, and then they have 7 million 25,000 and also 23 parameters, and then they have the same amount for the gradients. So it can be scanned and start training for 50 epoch, as we said in the coding. We need to have 50 epoch, and then it will scan one by one until the 50 epoch, and then the outcome will be sorry and then the outcome will be completed by showing the result like this: 50 epoch completed in 0.28 hours. So basically, 0.28 hours, it's only take around 40 minutes to complete the epoch scan. And then after that, we need to run detection on test image by inserting Python detect.py. So before this, we insert Python train.py. So this time we insert Python detect.py. So we need to detect our face mask detection from the video or image. So in this case, this is for image. So basically, there's around 50 image that we need to scan, and after that, the outcome will be 15 labels saved to run detect exp labels. So the data detection, the image detection is currently successful. Right, after that, we need to show the result from this image detection by use OpenCV to display the detected image, which I detect in above cell, this one, and then by using image equal to cv2.im imread, and then we need to set up the image height and also width. So basically it can show just like this, and as we can see, there's a person that wearing mask and not wearing mask. So basically YOLO have trained the data set, and obviously the the result is successful. Let's take a look at this. This man here are wearing mask. So basically the YOLO V5 has detected that the man is wearing mask at 0.91. So basically the others, like this woman are wearing mask, but this man that with potato is not wearing mask. So basically, obviously YOLO will detect the man is not wearing mask. Right. So after that, I continue on video detection. For this, we need to detect on test images, but this time we need to detect on video. So before this, we have successfully trained our data set to detect images for people that are wearing face mask and people that not wearing face mask. So on this part, we need to train our YOLO to detect data set. Oh, sorry, to detect video person that wearing face mask and also not wearing face mask. So basically, we insert Python detect.py, and the source from video mask video.mp4, the video that we have download through YouTube. And then after that, automatically YOLO V5 will scan the every parameters, every layers, and then the video is around the time that takes for this to fully scan or fully train is around 3825 milliseconds. So basically, this is the longest time to takes to scan or train the dataset. So basically it takes a lot of time. I think around an hour to take this coding successfully scan or train their dataset. Wait, okay. So the result after that, if the video has been successfully detected, the result will save to runs to directory file to runs detect, and then exp3. So basically this is my local file. So I will put the outcome of the what we call it, the outcome of our video that we use to scan. We use YOLO V5 to scan is in exp3. Right, so this is the video after we scan. So if you take a look at this, the YOLO V5 have successfully trained dataset that we insert, and this is the outcome. So basically, it shows that there is a person with mask, and this is a person that are not wearing mask. So basically, the YOLO V5 can differentiate every time there is two different two different element that we use to train YOLO V5, so that it can uh, differentiate a person that are not wearing mask and also wearing mask. So along the video, YOLO V5 successfully detect. So this is the perfect example that we can see. So this is the time that this woman are not wearing mask, and then what happened if she wear her mask back, automatically the YOLO V5 detect that the woman is wearing mask. So basically, this uh, video detection is successful. Right, so so to conclude, um, our train so to conclude our task 2 detection, we have successfully identified object of interest without fall within the COCO objects class, and then we have construct 300 image. So after we use data augmentation, we have around thousand images, and then after that we have annotated the data set accordingly and using that data augmentation to increase the training image number. And then after that we train the data set using our choice of custom yellow model, and we call it outcome, so both images and also both images and also video. And then after that we record the video and that contains object of interest, so we record the outcome from the video itself like this, and we have successfully using and evaluate the custom YOLO performance using the recorded video. Right, so that's all from me. Thank you. Assalamualaikum.